faster than the fabric of spacetime can comprehend. It will simply rupture. I am already terrified by this. Our evening sky is changing rapidly, and in a few decades, if not earlier, it may become completely unrecognizable. Astrophysicists worldwide are sounding the alarm. Experts like Neil deGrasse Tyson have recently confirmed the forthcoming explosion of Polaris, and the story behind it is quite chilling. Polaris, also known as the North Star, has long been a constant in our nighttime sky, serving as a critical reference point for astronomers, navigators, and scientists. However, this could soon change, altering our night sky and cosmic measurements. Let's explore the significance of this danger and its implications for all of us. Join us as we uncover the tale of Polaris as it nears its demise. For centuries, Polaris has guided sailors and stargazers alike, maintaining a revered position as a beacon. Its unwavering presence in the night sky has been essential for navigation. However, this stability may soon be disrupted. In September 2023, a paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial light. Polaris is on the brink of exploding, potentially disappearing from the night sky permanently. Before we dive into the consequences of this discovery, let's learn more about Polaris, also known as the North Star or Pole Star. Polaris is distinctive due to its proximity to the celestial North Pole. Positioned directly above Earth's north pole, it appears nearly stationary in the northern sky, located in the constellation Urim Minor or the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, significantly larger and more luminous than our Sun. It is not a single star. However, it is part of a complex triple star system, with Polaris A and Polaris B forming a double pair while Polaris B orbits them. The interactions among these stars generate gravitational forces, influencing their orbits and affecting their behavior. Any disruptions in these interactions can lead to irregular fluctuations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these connections remain unclear. Polaris is situated around 323 light-years from Earth, meaning the light we see from it today started its journey centuries ago. Therefore, if Polaris were to explode right now, we wouldn't notice it until over 300 years later. It's even possible that Polaris has already exploded and we're still waiting to observe the light from that event. Over the centuries, the North Star has held tremendous cultural, navigational, and symbolic significance. Its reliability and fixed position made it a valuable guide for ancient sailors, helping them navigate across seas and lands. Symbolically, Polaris represented stability and direction, remaining steadfast amidst the ever-changing night sky. For astronomers, Polaris has served as an essential reference point, aiding in the study of celestial motions and variable stars. As a Sciate variable star, its periodic changes in brightness have provided critical insights into stellar properties and the nature of variable stars. This feature has also played an important role in determining astronomical distances and calibrating instruments. These oscillations follow a predictable pattern which has been the norm for the star, making it easy to anticipate its behavior. However, recently, Polaris has deviated from this usual behavior. This irregularity in its pulsation cycle has baffled astronomers, prompting further examination of this celestial anomaly. Instead of its typical reliable rhythm, Polaris has begun exhibiting erratic dimming patterns, leading researchers to suspect that the star might be nearing the end of its life. This aligns with behaviors typically seen in stars nearing their end. The gradual elongation of Polaris's pulsation period, which was once steady, can be attributed to interactions within Its star system we've observed an annual increase of 4.5 seconds in its pulsation cycle, which might seem trivial, but it carries significant consequences. Some astronomers suggest that gravitational interactions between the Polaris stars might be responsible for these changes in its atmospheric conditions, directly influencing its pulsation patterns. However, others are more concerned, believing that the star is on the verge of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another famous star in the Orion constellation, are striking. Both stars have shown puzzling anomalies in their brightness, raising concerns of a potential explosion, as stars nearing the end of their life cycles often exhibit such irregularities. NASA has expressed heightened concern about Betelgeuse. However, formal attention has not been directed toward Polaris, as a SAID star nears the end of its life cycle. It goes through several stages, including the main sequence stage, red giant phase, and ultimately the supernova explosion. Given Polaris's erratic pulsations, scientists believe it has entered the helium exhaustion phase, common in giant stars nearing their end. These irregularities in Polaris's behavior are consistent with patterns observed in Psi-8 stars approaching their twilight stages. However, conclusive evidence of its impending supernova remains uncertain. Astronomers are carefully studying these inconsistencies to understand Polaris's future. If Polaris were to go supernova, it would likely be a spectacular event in our sky, potentially outshining the Moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance could dramatically alter, briefly changing our perception of recognizable constellations like the Big Dipper or Urim Minor, of which Polaris is a part. Rest assured, Earth would most likely be entirely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion may not be as visually breathtaking as Betelgeuse's, it could still be visible to the naked eye for an extended period and outshine nearby stars. Astronomers and observatories would certainly take notice, sparking interest among the scientific community and stargazers alike. However, the actual visibility and impact on Earth's climate or environmental factors would be less significant than that of a closer supernova. But what about Polaris itself? What will become of it after a potential supernova? One thing must be clarified: while massive stars typically end their lives in a supernova, this is unlikely to be the case for Polaris. When a large star explodes in a supernova, a tremendous explosion occurs, marking the last catastrophic stage of its life. This process involves a complete collapse of the core, triggering a powerful shock wave that causes the star to explode violently. However, Polaris is not massive enough to undergo such an event. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova, but instead result in a quiet end as it evolves into a small, extremely dense celestial remnant. A white dwarf is the remnant of a low or medium mass star that has used up its nuclear fuel. It is incredibly dense, roughly as massive as the Sun, but compressed to the size of Earth. When this happens, we will no longer be able to see its remnants from our planet, similar to how we no longer see the star today. Comparing the expected effects of Polaris's explosion with past supernova events offers valuable insights into the evolution of stars and their ultimate fates. Comparing our expectations with verified supernova events such as SN 1987A and later occurrences like SN 2011 Fe or SN 2014 J provides important data for understanding the potential outcomes of Polaris's explosion. For example, SN 1354 led to the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across various wavelengths, offering astronomers a rich field for study. Likewise, 1987A observed in the Large Magellanic Cloud provided insights into nucleosynthesis cycles and the elements of supernova remnants, including phenomena like nebula formation and the release of immense beams and variations in luminosity, which could offer valuable information about Polaris's unique qualities. The creation of clouds like the Crab Nebula results from the expulsion of material during the supernova explosion, which then interacts with surrounding interstellar gas and dust, enriching it with heavier elements and contributing to the cycle of stellar birth and death. Furthermore, the release of powerful beams and high-energy particles propelled by supernova shock waves has implications for astrophysical cycles and cosmic radiation conditions. To make a definitive comparison, researchers examine differences in mass production and the velocity of expelled materials between Polaris's expected explosion and other observed events. This includes studying light curve spectra and remnants from these events, as well as projecting similar features for Polaris' expected explosion, evaluating whether Polaris's explosion could result in the formation of nebulae or substantial elemental distributions. This helps deepen our understanding of its potential consequences. Another key area of research involves evaluating the pulsational variability of stars approaching their final stages, like Polaris, against observed supernova precursors. This comparative analysis can reveal similarities or deviations and provide insights into the explosion mechanism. Pulse variability in stars nearing the end of their lives may indicate internal instability or looming catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Despite thorough observations and extensive analysis, astronomers remain puzzled by the anomalies seen in Polaris's behavior. Unraveling the unique conditions driving these irregularities is crucial to advancing our understanding of stellar evolution. Grasping the mechanisms responsible for Polaris's unpredictable pulsations demands interdisciplinary cooperation and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a key reference point in the night sky raises significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would need recalibration, potentially affecting the accuracy of astronomical assessments. The disappearance of Polaris could also impact navigation systems and cultural practices based on celestial markers, underscoring the importance of this celestial event. The puzzling behavior of Polaris highlights the necessity for deeper research and focused scientific effort. Astronomers must tackle the complexities surrounding its irregular pulsations and provide meaningful responses, acknowledging the significance of advancing our knowledge of celestial phenomena. Ultimately, the fate of Polaris remains uncertain, and only time will reveal its true nature. Nonetheless, the quest for understanding in the face of profound uncertainty reflects the enduring curiosity of humanity in solving the mysteries of the universe. The potential consequences of Polaris's change go beyond mere cosmic curiosity. They touch on how humanity perceives its position in the cosmos. Throughout history, celestial objects have acted as markers of time and navigation, guiding explorers across unknown lands and seas. The loss of Polaris would not only disrupt traditional navigation but could also have lasting impacts on cultural traditions and myths tied to the North Star. In many cultures, Polaris has held a vital role in mythology and Spirituality, for example, Native American tribes have often seen Polaris as a guiding light in their stories, symbolizing hope and resilience. Similarly, the ancient Egyptians aligned their pyramids with the North Star's position in the sky. The disappearance of such an iconic star could reshape cultural narratives and the collective human experience related to direction and navigation. Additionally, the scientific community would face significant challenges if Polaris were to vanish. Cosmic measurements and observations heavily depend on established reference points. Polaris's role as a constant has been crucial for calibrating instruments and models used to study distant galaxies, star formations, and even the expansion of the universe. The sudden loss of Polaris would require recalibrating many systems, potentially leading to inconsistencies in measurements and understandings of cosmic phenomena as astronomers shift their focus to monitor Polaris more closely. New observational techniques are being developed. Advancements in spectroscopy and photometry enable researchers to analyze light emitted by stars with extraordinary precision. These tools help detect subtle changes in brightness which are essential for understanding the processes driving celestial behavior. As specialists GAGA more data, they hope to refine their models of stellar evolution, especially concerning stars nearing the end of their life cycles. The study of other similar stars such as Sides and red giants provides valuable insights that could prove critical. For example, astronomers are observing factors like the period luminosity relationship, which aids in estimating distances across the universe by comparing the behavior of these stars with that of Polaris. Scientists aim to gain a clear understanding of stellar dynamics and evolution, deepening their appreciation of our galaxy structure. Furthermore, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly significant. Understanding the characteristics of stars in triple systems can provide crucial insights into the formation and habitability of planets orbiting them. Astronomers are keenly interested in how such stars influence their surroundings, possibly affecting the conditions under which planets form and evolve. If Polaris undergoes a significant event such as a pulsation leading to a transformation, it could serve as a stellar laboratory for studying the life cycles of stars. These events would not only provide a window into stellar demise but could also shed light on nucleosynthesis, the process by which elements are formed in stars. The remnants of Polaris might enrich the interstellar medium with heavy elements essential for the formation of new stars and planets. The educational value of Polaris's potential explosion is also considerable.